So it looks like we're going to get about 20W is equal to, and I think I missed a 0, so if we look at this number, it should have been 11 times 500. So it should have been an extra 0 to get 5,500 minus 4,500, which is 1,000, divided by 20, divided by 20. Looks like W is going to be about 50 miles per hour. So the wind is actually not very fast in this case. It's mainly the plane, which is 500 miles per hour. And then if I was going with the wind, 500 plus 50 would get me to a speed of 550 miles per hour. Compared to if I was against it, would be 450. Like I said, the setup of this one's a little bit harder than most of them will be. If we look at number 4 is a little bit more standard, so this one will give you a better sense of like what the typical problem will be like. I think number 3 is good because it gets you a little bit more familiar with the distance, speed, time equation, getting used to that. So number 4 says a motorboat makes makes the trip 24 miles upstream against the current in 3 hours. So typically I do like trip there and trip back. So going there, it was 24 miles against in 3 hours. Returning, it was 2 hours, still 24 miles, and going with. And the things that they want us to find are the speed of the motorboat. So I'm going to call M equals, or maybe I'll do B for boat. B equals boat speed. And they also want us to find the speed of the current. So I'm going to do C equals current speed. When they say find the motorboat speed in still water, that just means how far does the boat go if the water is not influencing at all. So if I think about my speed equals distance over time, right? Speed equals distance over time. I want to try and do a trip there and a trip back equation. So my trip there, if I was to do that, speed equals distance over time. The speed is going to be going against the current. So my speed of my boat, take away my current, will be my overall speed. My distance is going to be 24 miles. And my time is going to be 3 hours. Okay, the other one is going to be speed equals distance over time. My speed is going with the current, so it's going to be boat plus current is equal to distance of 24 miles over 2 hours. What's really nice about both of these equations is that 24 over 3 and 24 over 2 are going to simplify. So what I would do is I would then write my system of equations. I've got B minus C equals 24 over 3 is 8, and B plus C is equal to 12. You can kind of think about that as, you know, the speed itself when you're going against the current is you have 8 miles per hour, and when the boat and the current are working together, your speed is going to be 12 miles per hour. These equations are a little bit easier to work with because we have more information than the previous problem. Most of these equations are really, really easy to just solve them by elimination. If you add your equations, notice the C's are going to cancel. You get that 2 times B is 20, which means B itself is 10 miles per hour. And if the boat is 10 miles per hour in still water, we could say, oh, well, I know that 10 plus C equals 12, so the current equals 2 miles per hour. Okay. So once again, like strategies for these kind of problems is making a table and putting your information. And then you always want to plug it into the speed equals distance over time formula in order to solve for your missing variables. I'm going to skip past number 5 because number 6 is actually more similar to the one we just did. What I want you to do is I want you to pause the video and I want you to make a table. Make a table of all the information that you can find. Okay, so here is my there and back. I've put the distances, which is the same, and the time. Now, they did not tell me which one is going with the current and against the current. Some students focus on the word like downstream and upstream. That's not really going to help you at all in figuring out if you're with or against the current. The thing I look at to tell if I'm with or against the current is the time. So if it takes me 6 hours compared to 9, whichever one is faster, you're going with the current because it's helping you. Whereas the second one would be against the current because it's taking a longer time. So that's always my first step. So step 1 is my table. Step 2, use speed equals distance over time to get my equations. So for my first one, speed equals distance over time. The speed, if I'm going with the current, it's going, and I need to define some variables first. We are looking for the boat and the current. So I'm going to call B my boat speed. I'm going to call C my current speed. And I actually want you guys to try and use the speed equals distance over time. Try and write your 2 equations for there and back on your own. And then I'm going to unpause the video after I've done some work. Okay, so I've got my speed equals distance over time. For the first one, my speed, if I'm going with the current is helping me. So my speed is the boat speed plus the current speed. They're combining together equals my distance, 108 divided by my time, 6 hours. And then a simplified equation is boat plus current speed. It's going to be 18 miles per hour compared to when they go against each other. When my boat minus my current speed, I'm only going to be going 12 miles per hour. So the nice thing about these, right, just like I said in the last example with you guys, is when you put them together, you can really easily just use elimination and add them. The C's are going to cancel, and 2 times B is equal to, it looks like 30. So my boat speed is 15 miles per hour. And let's see, if boat plus C equals 18, and I know boat is 15, that means C equals 3 miles per hour. Now this is a pretty typical problem. So after the second one, they should be coming a little bit more straightforward. Again, apologies for doing the trickier one, number 3 first. Number 3's got a little bit more going on because they don't spell out exactly what you're looking for. I would say if you can do number 6 and number 4, the 2 motorboat ones, you're good. I will be posting an AM support worksheet, and it's got like lots of word problem practice. So if you feel like you want practice with like the speed, distance, time stuff, I'll be posting that on Google Classroom, and you can get some good practice from there. I do have one more practice problem, so we're going to go in a different direction from our boat problems. This one, number 5, which you can call it 6 if you call the other one 5. This one is about a factory that is doing a mixed nut bag. So mixed nuts cost $8 a pound, and they're made by combining walnuts, which are $6 a pound, with peanuts, which are $12 a pound. And we want to find the number of pounds of walnuts and peanuts required to make the correct amount, 6 pounds of the mixed nuts. So this one's like a mixture problem. So this one's going to feel a little bit more like when we did our mixtures like saline with salt and water or hydrogen peroxide. So defining our variables, I'm going to call W my pounds of walnuts. I'm going to call P my pounds of peanuts. It's a little bit easier just to be consistent rather than use X and Y with the letters in the problem. Makes it a little bit easier to kind of read through it yourself. Now, because there's only 2 variables, I'm looking for 2 equations to write my 2 variable system of equations. So let's see. Remember, the gimme is always about your total. So if I want a total of, let's see, 61, or excuse me, a 6-pound bag. If I want a 6-pound bag, I need pounds of walnuts plus pounds of peanuts is equal to 6. Yeah, if you want a 61-pound bag of mixed nuts, you might be a squirrel. So that's always the easiest one, right? It's the total. You know that they have to add up to 6. And the second equation is normally the one that we include our percentages, kind of like if we go back to the other problem we did, if we go back to like number 1 and 2 with the del and the saline, right? You typically have percentages somewhere. This one, instead of percentages, we're going to be including a price in some way. So let's see. Typically we do percent times the amount. Let's try price times the amount. So if I have walnuts and they're $6, $6 times how many walnut pounds I get, plus $12 times how many pounds of peanuts I get, should be equal to $8 times however many total pounds. Remember, my total pounds is 6. So for this, you want to do like money times amount. Really similar to when we do percent times amount in the other problems. So the way that this works is this is saying like $6 times pounds of walnuts. So if I got 2 pounds of walnuts, it would say that's going to cost you $12. Plus however much money the peanuts cost you should get us a total of 8 times 6, or if I write that out, 48. And this is a 2-variable system, so this is one that you can definitely solve by hand. Remember, if you want practice with your calculator using a matrix and reduced to our echelon form, you can just use any of these systems and try them on your calculator. Notice you'll have a different amount of rows and columns than the other problems, so you'll want to be careful with that. I'm looking at the top equation, and I'm thinking if I just did this one times -6, that would be pretty nice. I'm going to work out the math and unpause in a moment. Okay, so I decided to multiply the top one by -6 to get my 6w to cancel out. When I added, it looks like I got 6p is equal to 12, which means p is 2. So that means I have 2 pounds of peanuts, which means if they have to have 6 pounds total, the walnuts have to be 4 pounds. I'll put my units there. So 2 pounds of peanuts and 4 pounds of walnuts. If you were to do the pricing on that, right, 2 pounds of peanuts would be 6 times $2. 4 pounds of walnuts would be 12 times 4. That's going to be 12 plus, oops, did I write something funny? I think I wrote something funny. So figured out my mistake. You're probably all yelling at the computer screen like, Miss Goldenberg, what are you guys doing? So I switched my numbers here. So 6 times W, it should have been 6 times 4. Because I have 6 pounds of walnuts at $4 each pound, plus 12 times 2. Should be 24 plus 24. It does get us to a total 48. Before it was not adding up correctly, and it had me getting a little confused. So overall, these problems, these are our word problems. They're in 2 categories, typically these ones. We have mixture problems, right? So the first couple were mixture. Number 5 really should have been moved to the mixture page. It just got kind of mixed up, so to speak. There's a good pun for you guys there. Number 3, 4, and 6, those are all really good speed equals distance over time problems. Number 6, this work laid out is a really good sample of like what the typical problem will look like. So these are 2 types of problems to make sure you're seeing the patterns that we're doing. So a good study strategy, right, would be there's a name support worksheet. Try and write out like general steps for the speed equals distance over time problems, as well as your mixture, right? Like try and think to yourself, like what are the general steps that I do every time? You could write out an example problem, but that will help you kind of consolidate your understanding of recognizing and seeing the patterns in the problems. Okay, good job guys. I'll see you tomorrow for some more fun math. Hope you guys are enjoying doing math at home. Hope things are making sense so far. I'm looking at trying to figure out some kind of an office hours with a video chat feature. So I'm going to probably be posting in Google Classroom and seeing what time would work the best and getting a poll from you guys on that. Okay, bye guys.